Hi everybody, here's Christian from Lazy Devs, and this is now the time to do the final boss of this project. We are going to rewrite the collision detection system once more. I'm sorry, we have to do it. I know episode 7 was horrible and because we did some really horrible stuff, but now it's time to undo all of these things and do it right. Here is why. I figured out when I was doing some level design, I figured out there's one specific type of problems that occur over and over again in our program. One specific type of collision that doesn't really work very well consistently. Not just like, oh, sometimes it doesn't work, like once in a blue moon, but you really like something that really happens like once every playthrough, so to speak. And so here is, I'm gonna try to, I did this recording once more previously and I didn't turn off some overlays and it was horrible. So let me show you real quick what the problem is that it's really consistent. The problem occurs with indestructible bricks. So let's say you have two bricks which are indestructible, right? And now let us think that we are actually bringing in a ball. So the ball flies, and usually it's like, okay, collides here and then it flies away, right? But the problem is what happens when the ball collides with two things at the same time in one frame, like this, bam. We collided with two things at the same time. Well, right now, the way we wrote our function is we find a collision, and if we found the first collision that we find, just going through the array, not even like looking what is a close collision or far away one. The first collision we find, we react to, and all the other ones we ignore on this frame. So what happens is with those indestructible bricks is you land in the collision, you get reflected maybe in this direction, and then on the next turn, on the next frame, you actually start collided with a brick. And, usually when the bricks are not indestructible, that's not a problem because, okay, you collide once more, the bricks disappear, and, you're scot-free. The ball can fly around and fly away. But if the bricks are indestructible, then the ball will start bouncing around within the brick because it constantly keeps colliding, constantly keeps reverting its speed to try to kind of like, because it constantly collides with the same brick. It's a big problem. The problem probably should occur, haven't seen it yet, but it should also occur when you are collided with the brick, with an indestructible brick and the edge of the screen. Also a big problem. Two collisions in one frame is something that our system is just not really good to deal with. There's another problem that is kind of like haven't even seen because it's quite subtle, but it's also something very important, and that is Let me show you. So the brick is flying, and there is like no special collision. It's just a very simple collision, right? So the brick is flying, the ball is flying, and so suddenly the system realizes, okay, well, next time we're going to be here inside the brick. So what it does then is, okay, I'm gonna reflect it now. I'm not going to even move the ball towards the brick. I'm going to reflect it immediately. But that also leads to a weird situation where our balls never really touch the bricks. They bounce off a little bit in front of the brick. Not a big deal because our balls are currently moving very, very slowly. So not a big deal. But, in the future when we, well, I guess we don't actually have anything that will increase the speed of the ball. But, if you guys want to make, for example, a more difficult version of the game where the balls are flying faster, then it's where it starts getting really difficult. So kind of like these two problems is our collision system cannot deal very well with. Multiple collisions in a single frame, especially with objects that don't disappear. And also kind of like figuring out like collisions that are more precise, where the ball actually goes to the moment or to the point where it collides with. And so this also already maybe gives you a hint on what we are going to do, how we're going to rewrite our system. I actually Googled this problem. And I have to apologize. If I knew that this was so difficult, that this was such a well-known, well-established, well-documented problem, I probably wouldn't have done this as my first tutorial. But it's kind of like, I'm learning about this myself. Like, this is also interesting for me. So this is a website called Code Incomplete, and I'm not exactly sure how the author of this is called, what his name is. And on GitHub, he's called Jakes Gordon, so maybe that's his name. He wrote a Breakout game once in the past. And so he goes here, this is 2011, he wrote this in Java, and he goes through some really interesting, he described his procedure, how he made collision detection work. And he had a lot faster balls, and he really explains a lot. So he is really interesting because he actually went ahead and made the collision between, made the system so robust it actually dealt with multiple collisions per turn. That's actually pretty cool. But on the diagrams, we already see kind of like what he's up to. His collision detection is very different. For us, it's like you have two objects, and if they overlap, there's a collision. And then we had like this very complicated function in episode 7 where we tried to figure out, how to deflect the ball after two objects are entangled. So he wrote it differently from the get-go. So what he did is he has a function that finds out where along a trajectory a ball will collide with a brick. It actually finds this interception point between the surface of the brick and the ball, finds where the ball will hit the brick. And then from this intersection point, he can actually move the ball to the brick, to the surface of the brick, and then continue doing collision detection from there to do multiple collisions per frame. Not going to do multiple collisions per frame. We could, but we won't. I don't think it's necessary in our case. But what I'm interested in is this function that does the interception. That's actually pretty cool, right? So let's try to adapt our system to use this function. We will have to rewrite a lot of stuff. We will rewrite things from scratch. Here's this code, and here is the function I was talking about. It's called intercept. And again, this is Java. You don't have to understand it because we are working in Lua. But it's not that different. Like there's some curly brackets that we have to deal with, but otherwise it's the same if-then statements that we had before. Now, this function accepts 4 sets of variables, or 4 sets of coordinates, and 1, 2, 3, 4, and x and y of each. So 1 is the position of the ball, so to speak. 2 is where the ball will be. There's like a line between. You could draw a line between where the ball is and where it will be. And then 3 and 4 is another line. That is the line that we are trying to collide with. So basically, what all this position does is to find out if 2 lines are intersecting. To find an intersection. And if there is an intersection, it will tell us exactly where they intersect, what the coordinates are of the intersection. That's pretty neat. Not sure exactly how this function works. I fully assume this is vector math, and this is something like a standard equation that you can look up in some kind of mathematics book, how to make 2 vectors, how to figure out the intersection between 2 vectors. So we're not going to actually, take it apart and understand how it works, because probably, this is some kind of smart mathematician in the past with like a long beard figure this out, and we're just adapting this. But maybe what's noteworthy is how we know where the collision took place. And this return thing. I don't know if this is big enough for you guys, but it returns an actual object. So it doesn't just say true or false, there is collision or not. It actually creates its own little object that tells us about the collision, a collision object or a collision information object. So this object has an x coordinate, a y coordinate of where the collision actually is, where the intersection point is. And it also has the d. Well, the d is something it just passes on from whatever called it. It's an argument that is passed on into the object, and we will use this d as the description of what this collision was, what kind of collision we're talking about. This will become clear very, very quickly, but it's going to be very cool. It will allow us to do a lot of things that we did in episode 7. We covering with that single function. That's pretty neat. Maybe something noteworthy, when there is no collision, it will return null, kind of like an empty object, like a non-existing object. So if there's no collision, there is no object that we will create. This is the thing, and now I will actually turn this thing off, click, and load our hero, and we're gonna try to rewrite this using this. So I will create a new tab, and we'll call this new collision. And I actually I actually made sure that this actually works. I wouldn't lead you down a path when we're doing this kind of rewrite that won't result in excellent results. So this is the function that he wrote, and I rewrote this to work with our program. There's nothing different with this. I will show you the entire code, but I would suggest to actually take a look at the pastebin code and take this intercept function from the pastebin code, because this is, there's a lot of variables in here, and it's very easy to make some mistakes. So again, it accepts 4 sets of coordinates and a d, but this d is kind of like a variable that just passes on into the return object. This is where we create our return object. This is where we actually found out a collision. Just making sure that I made everything correct, because it's so easy to make some kind of mistakes when you have this kind of crazy, yeah, no, but it looks well. This kind of crazy thing. Okay, so easy. Intercept function covered. We have an intercept function. It doesn't do anything yet because we're not calling it anywhere. So where are we going to call it? How are we going to implement it in our program? Well, this is where then the next part comes in. And let me show this real quick again. So let us continue looking at his code. I'm going to steal a second function from his code. So this is where this this entire function is where this intercept function is being applied in. So this is called ball intercept. This function is called ball intercept, and it accepts an ball object with information about the ball. And it accepts a rect object, which is a rectangle. This rect object has like multiple qualities, multiple properties. It has a left, right, top, and bottom property. These are coordinates of, the x coordinate of the left edge, the x coordinate of the right edge, the y coordinate of the top edge, and the y coordinate of the bottom edge. It's kind of like a typical thing that construct that describes this as a rectangle. We're not using this as a thing like this, but I will actually start using this here because it's kind of really neat, and I like the English properties of it, like left, right, top, bottom. That kind of makes more sense than x plus width. That's kind of like that you have to do like some math in your head for this, and so your collision might get a bit messy. We probably should have done this from the beginning, but you live and you learn. What else? So it receives this rect object, and it also receives nx and ny. Nx and ny are, in this case, the vector of the ball, so kind of like where his speed, the speed of the ball. For us, it would be dx and dy. He just called it nx and ny. And the way this function works, basically, it says, like, okay, if the ball is flying to the left, if nx is smaller than 0, in this case, please make a collision detection between the line that our ball describes, the vector of our ball, and the right edge of the box. So here's a box. Let's see. I have to look at my camera. Everything is mirrored, and the ball. Do I have a ball? Do I have something that is a ball? Let's see. Let's take this tiny little controller. This is our ball. So the ball is flying, let's say, to the left, to the right. This is right. Oh my, this is so difficult. The ball is flying to the right. It will only collide. It will only check against the collision with the left edge of the box that we're trying to collide with. Huh? So this is actually really neat because it actually doesn't do like an intersection, like, okay, are two objects intersecting each other? Are they overlapping each other? It doesn't do that. It checks, it picks, cherry picks the edges that it checks the collision with. So if the ball is maybe for some reason inside an object and wants to fly out, it won't actually stop it from flying out of an object. It won't register a collision if the ball is already inside an object, technically, in like most cases. Which is really great because we get less, if there's an error, we get less problems of objects getting stuck in each other. So it checks only for the edges that are relevant to the trajectory of the current ball. So again, it checks for right and left edges, depending on whether the ball is flying to the left or to the right. And then if this didn't found a collision flying to the left or right, it will check bottom and top edges of the box. And yeah, and if ever finds a collision, it returns that collision, the first collision it finds. Again, the first collision, so if it fits directly the corner, it will tend to go to the sides, because this is the first collision that it looks for. Okay, now, again, this is the problem. I recorded it once and it didn't turn off the Google window, so that was a really horrible thing. So again, I rewrote this in Lua. And this time I made some changes. This time this is not a perfect copy. This is called ball intercept. It will accept a B object. This is going to be our ball. We already have ball objects in our program. It also accepts a box object. We don't have box objects in our program yet. We're going to have to write some functions that will create box objects, but we're going to use this function to make collision detection between the ball and the screen, the ball and the paddle, and the ball and the the bricks. So 3 different types of object we're colliding with, and for each object we can just generate kind of like a description object, which is going to be a box object. And then I have an x and an y, slightly different than in his version. For my version, this is not the speed of the ball. We actually have to store in our b object. This is not going to be speed of the ball, but actually the next position of the ball, the actual coordinates. This clarifies a little bit some part of the code, this part in particular. Okay, so nx and ny is the next position of the ball. Very important. And we're going to create the pt. pt is kind of like point. I guess it's point. And it's a nil, so it's empty at the beginning. And then first, we're going to actually check for the bottom and top collisions. First, the bottom and top. Why? Well, I don't know why he prefers the sideways collisions, but for me, in my head, the rectangles we usually have are like very elongated and you know, have very small sideways edges. So most of the times we're going to do collisions up and down, and we're going to rarely do sideways collisions. So I think most of the times it will look naturally if the ball reflects to the top and to the bottom. So I prefer to do those more frequently. Just making sure that all the code is correct here. Yeah. So for example, let's go through this code one more time. So if it finds that the next position, y position, is going to be smaller than the current y position, so the ball is flying upwards, then it will use our new intercept function to derive a collision point, if there is a collision point. And so it will give this intercept function the coordinates of our current coordinates of our ball, the upcoming coordinates of our ball, where it will land in later on, and then left bottom, right bottom, basically the left bottom point and right bottom point of our box. But here's something that is interesting. We also this is a bit weird. We are also adding the radius of the ball. Why? Because we are trying to find where the ball will touch the edge, where it will actually touch the edge, where it will go. So we have to actually kind of like, because the ball is always, of course, the center of the ball. Let me see my camera. So the center of the ball is kind of like in the middle of the ball, and there's like the radius of the ball around it. So if we didn't add or subtract the radius of the ball, our ball will actually go into the objects, will visibly go into the objects. So we offset the edge by the radius of the ball, kind of like move it closer to the center of the ball, so to speak, so that our ball will actually reflect earlier than it would if we took just the center. Kind of like taking into account that our ball actually has a radius. It's actually thicker than a single point. Just a little detail. Okay. I don't like this that there's me. I just noticed that there is a minus r, and I don't like this. I'm thinking about this. Okay, never mind. Whatever. Later. Good. So and you can see here a variable that I was talking about, this bottom variable. So this is the d that we had in the intercept. You know, you had the 4 sets of coordinates and a d, but we don't actually do any math with the d. We just pass it on into our collision object here, the d. D means description in our case. So we actually say what kind of edge we were checking against when we did our collision detection. And this allows us later to do like a correct reflections. We know that, okay, this was the bottom edge, so our ball should fly downwards. And if the ball is not flying downwards, then something went wrong. We have to deal with this. And again, same thing with top, right, and left. Cool. Okay, so this is this function, and oh yeah, by the way, so just to make sure, I don't know if I already talked about this, but I just want to make sure that everything is clear. So first we check for top and bottom edges, depending on which direction the ball is moving. If there was no collision, then we check for the right and left edges, depending on which direction the ball was moving. Easy peasy for breezy. All right, so now there are some additional functions that I want to add that will help us. Saying it immediately because for some reason we just managed not to have this, but I think we should have this. So here is a function that we're gonna need. It's distance. It's a function that a lot of programs have, and I'm kind of like flabbergasted that we didn't need it for now. It's calculating the distance between 2 points. Just easy. It takes x and y as 2 sets of coordinates, and it uses the Pythagoras function. It's kind of like, you know, like a right-angled triangle. Look it up. It's easy. It's just a function that just calculates the distance in pixels between 2 edges. And, you know, it takes diagonal distance into account. So you have like a nice little precise calculation between 2 points. I don't know what's called in English. Pythagoras? Pythagoras? I guess it is. So this is something that we're going to need later on. So let us start writing the collision detection. I don't know if I did it last time around, but this time around. So what we are going to do is, instead of reacting immediately when we find a collision, that's bad. Because again, we're trying to deal with a situation where there's maybe multiple things that we collided with in a frame. So what I want to do is the following. This is something that we're going to do. We are going to first collide the ball with everything that we have in our game, with all of the edges of the screen, with all of the with a pad, with all of the bricks and stuff like that. All of the collisions, we're gonna check for those intercept points, and we're gonna put all of those objects that say, okay, you collided with something. We're gonna put all of these into a array. And then once we have like a list of all of the collisions that could be happening when we move the ball, we're going to pick the one that is happening next, the one that is nearest to our current position of the ball. That's why we have this distance function that we have. We're going to measure the distance to all of the collision points that will be happening in the next frame. And we're going to pick the collision that's going to be happening first, the first collision that will be happening when the ball is traveling along a path. And then we're going to move our ball to that collision point, where it's actually touching the thing that it collided with. And that's it. And then we're going to do the reflection, stuff like that. And in the next frame, we're going to continue flying with the ball and colliding with more stuff. So we're not going to do actual multiple collisions per turn. We're just going to do one collision every turn, but we're making sure that it's going to be the next collision every turn. And we're making sure that we're moving the ball to the position where it actually collided. Not, colliding earlier, not reflecting it into something, just moving it to where it was supposed to be, or where it collided. This would mean that if the ball is flying really fast, it will slow down when there's a lot of collisions. It will seem as if it's stuttering or slowing down when there's a lot of collisions happening. But since our ball is not moving that fast anyway, we won't having any issues. Again, we could be doing like multiple collisions per turn, but not necessary in our case. Good. So let us look at what our current collision function looks like, and let us just rewrite this. So this is draw. What we want to have is update ball. This is where things was happening. So I want to I'm gonna rename this to update ball old, and I'm gonna copy this function all the way down here to check if the ball hit wall. This is where things are happening. And I'm going to paste it in here. This is going to be update ball, period. Just update ball. So if my ball is stuck, which means it's stuck to the pedal, do nothing. Otherwise, do regular ball physics. And here everything is fine, or there's a timer that changes the speed of the ball, but that's also okay. And there is the next X and next Y. These are also important. I don't know why I think I copied it multiple times. Okay. check if ball hit wall. I'm going to put an end here, and I'm going to put an end here, end of stuck if, sticky if. And just making sure that all of the if statements are closed and everything. If you can remember, because this was a very long function, and if you remember when you actually go there, scroll the way through, and we actually made sure that we know there's supposed to be two ends at the end. So again, so let us start doing these things. I want to create, let me see how I called it when I first coded this. So I want to create an array or a table that contains all of the collisions that will be happening in the future. All of the collisions. So let's do something like this. Local calls all the collisions that will be happening. It's a local variable. It will, we're just going to use it once for every ball, and it will disappear at the end of the function. And also maybe another would be local underscore temp call or t call maybe. No, let's go temp call. TMP call. That's kind of like a temporal collision that we're going to put the results of our collision functions in. Okay, check if ball hit wall is something that will happen afterwards. So we defined a collision now. We defined a table for collisions now. Now let us do an actual collision. So we're going to use this two new functions that we now have. So we're going to go temp call equals. And now this function is called ball intercept, right? Ball intercept. Ball intercept. Now my ball is called my ball. And now there's going to be a box. We don't know, some kind of box. We need to create the box object that we're talking about. And then next x and next y. Because that's what our ball intercept function requires. Now, then we're going to check if actually something came out of this. So if temp call is not nil, and we remember if there was if the result of those functions is a nil, that means there was no collision, so we don't have to deal with this. But if there was not a nil, then wait a minute. I thought it was like this, not nil. Kind of weird that it worked with the exclamation point. I guess that's possible now too. Okay, if it's not nil, then we're going to add this collision to our list of collisions. Like so. Okay, so that's basically what we're going to do, and we're going to do later on collision with pad and collision with bricks. And then once all of the collisions, we're not reacting to the collisions, we're just putting them in a list that this is something that actually happens in this turn. And once we're done with all of we've added all of the collisions to our list of collisions, we're actually going to start reacting to them. We're going to go through them and pick which one is the one that we're going to deal with this frame. So before we're moving on, let us make sure that we have this box here. So what I did actually is I called it screen box, and I created a box that is kind of like a standard box for the screen, for the entire screen. So I'm gonna put this kind of like a default thing here. So let's go like, I don't know, like something like one of the first things that we do, screen box. Let me search for this, because this is something that we're gonna have to make sure that is not buggy. Yeah, there we go. I'm just gonna paste it in here, so you know what's right and wrong. I'm going to actually make sure you can actually, especially in a definition like this, you can actually make a line break. So these things align underneath each other, so we can actually better read what's happening. It's a bit weird what we're doing here, because we're misusing the system a little bit. As I said, the ball flying to the left, it will actually try to, okay, again, I have to look at my camera. So if the ball is flying to the left, to the left, it will try to check. Oh my gosh, this is. It will try to check the left wall, the collision with the left wall, right? To the right wall of the box, because it's trying to collide with the right box. But now we are trying to do a collision with the screen, so we have to put the left there. The right should be the left and the left should be the right, is what I wanted to say. And the top should be bottom and bottom should be top. A bit complicated. So that's why we're saying left is 127. That should be the right? 127 is the right edge of the screen. But because kind of our screen is an outside-in box, we're switching all those edges around. Because if we didn't do this, the ball would just fly right through our left edge of the screen because it's looking for the right edge of a box. Oh gosh, this is getting very complicated. But anyway, so this works. I tried these numbers and they work very well. Very important is that top, so kind of like the bottom edge of the screen, is at 140. So the ball will fly very, very, very deeply down. Because we're going to do the the checking if the ball has left the screen on the bottom. That's something that we're not going to deal with in a kind of like reflection kind of way, but then it's actually, we're going to do like a hard check if the ball position is below 127. Okay. Good. So, but right now, if we run this, we could run this, right? Nothing will happen because the ball is not even moving. So we're gonna have to do some more writing. Let me see. I want to have what I wrote previously, just so don't make any really stupid mistakes. Okay. So this collision. Let us start trying to move the ball. So there's an easy thing. So after all the collisions are done with, see if there's collisions. Because maybe there's no collisions, and in that case, we don't really care about anything. So after we're done with, we're gonna just see how many entries we have in our collision. So if hashtag calls is 0, then all right, no collisions. Otherwise, sadly, some collisions. So here we say no collisions. That's the ideal situation, right? And if there's no collision, then we just set the position of the ball to next x and next y. Let's see. Where do we do this? There we go. Next x and next y, like this. See? This is what will usually happen. Otherwise, if there is collision, difficult, man, difficult. So when we're gonna run this, we should have the ball fly all the way up to the screen and then stop. Works. Good. So from here, we're gonna do this thing where, okay, so there are collisions. How many collisions are there? Because if there's just one collision, you're just gonna collide with this. If there's multiple collisions that we found, we're gonna actually have to find the distance between all of the collisions and find the one that has the closest distance to our current ball position. And this is the one that we're gonna deal with, because the other ones will happen afterwards along the trajectory. So maybe, the ball gets reflected and won't actually collide with those other things that we detected. Okay, so how are we going to do this? Yeah, okay. I have like this code here and I will just step through this because this worked well. So in other case, there is some collision, right? We have a call I, that is kind of like the index of the collisions we're talking about that we're going to take. And if the number of collisions is greater than 1, if it's greater than 1, there's more than one collision, and then we're going to do some kind of stuff. Otherwise, wait a minute, there's one end missing. Otherwise, this is kind of like the part of the code that will find the closest collisions. Otherwise, we're going to deal with the collision. And I think it's a good idea to create a new function for this because this is already getting very complicated. Collide. Then we're going to collide my ball with underscore cols underscore col I, the index of the collision that we picked as our collision. Oh, that's not the right one. That's the square brackets we want here. And in a second here, I'm going to step you also through. Jesus Christ, why is it not working? Okay. In a second here, I'm going to step you through the procedure that picks the closest collision if there's multiple ones. So if there's multiple, so here's the question. If there's multiple collisions that we're going to have to pick the best one from, more than one collision, find the closest. So first we're going to take kind of like the first collision in the thing as the collision. We're going to calculate the distance between the first entry in the list and the ball. We're using here the call dist function. That's actually a wrapper to make things a little bit more easier. I'm going to actually copy this one here. So this was the distance function, but I also have like call dist function. So that accepts a ball and a collision object. And it will just, you know, take all the variables outside of the ball and a collision object and plug them into a distance function. So it will kind of like, it's a wrapper, basically makes the distance function work with the ball and collision object. So we don't have to extract, you know, x and y out of the ball and a collision object. Just, you don't need this, but it was kind of neat here. So call dist, the distance between my ball and this collision. We're going to take, actually, no, this one, and the collision 1. That's going to be kind of like our starting distance. That's kind of like the reference distance, so to speak. So we're going to starting out here, and now we're going through all of the collisions. Kind of, we could technically start here at number 2, because if there's more than one entry, then it has to be starting at number 2, right? So we're starting at 2 and going through an entire array. And we're checking if we're calculating distance, local DST. Oops, Jesus, I didn't want to do this. We're calculating the distance between the second collision here, calls I. The I refers to the variable of our loop. So we're looping through all of their collisions. And if this new distance is smaller than the reference distance that we had at the beginning there, then our reference distance becomes this new distance, this smaller distance now. And also we save the number that of the collision in the array that had the reference distance, the new reference distance. So we kind of like remember this for later. And then we continue going through this. And once we are through this entire process, then we should have, you know, the closest distance should be saved in call dist, and also the number of the collision that has the closest distance to our ball should be saved in call I. And so, you know, then we continue as we had before, where we're just going to collide the ball with the collision that we saved in call I, the number of the collision that we saved in call I. Very verbose way of describing things. One more thing, now we have to do the collision function, where we're actually colliding with stuff. This is now where the rubber meets the road, I guess. Let me see, how did I write this? Okay, so underscore B for the ball and underscore C for the collision. Okay, so first we're going to set the position. So again, if there's a collision, we're setting the position of the ball to where the ball touches the thing that we're colliding with. Like so. Easy, right? And then we are actually talking about reflecting the ball. So if C dot D, now we're talking about the description of the collision. The description of the collision. Again, remember, we in our function describes which edges we are colliding with, top, right, and so forth. Right? So now we're looking at those. And depending on what kind of collision we are having, it will reflect differently. So if it's left, oops. Then otherwise, and. So left or see, oops, d equals left or right, obviously. Now here, if you wanted to have a really nice and robust collision detection, we could actually make sure that if we collide with the left edge, so our ball is flying to the right and collides with the left edge, and that it will actually go to the left. That will not reflect if it collided in some kind of weird way. But I don't think it's necessary. So we just can invert the speed here. And if we see some kind of issues still, we can still make sure that it's a little bit more robust. So, you know, here we reflect it we reflect the dx speed. Otherwise, we reflect dy speed. Cool. And you know what? That might actually already start working. Forgotten underscore. No big deal. Oh no, it's still not working. What is wrong? Oh yeah, right. I wasn't paying attention. Okay. Hopefully, come on, fingers crossed. Come on. Yes. See, it starts colliding with stuff. Easy peasy for breezy. So you can see this is already working well. Whew, that wasn't so hard, right? Good. So let us continue doing more collisions. So before I make the ball actually die when it leaves the bottom, I wanted also to do the collision with a pad. Now here's something that we have to do. We have to create this rectangle object for the pad, the object that is left, right, top, and bottom, and stuff like that. We have to actually create this object, which is not that difficult. Let me see real quick. And this is something I also saved up for. I wanted to do some big change here. So this one going to be interesting. Okay, where is it? Where is it? Check right. So I'm gonna do something like this. I'm gonna create a local. Actually, I'm gonna create it here. Local. Let's go call it local underscore box. And we're going to create a new function called getPadBox. So that function will just create an object for us that is going to be encompassing that we're going to describe all the edges of our pad. And I actually have this function in here. So remember I talked about stuff like I don't like how the pad, when it grows always to the right. Wait a minute, to the right. It's always mirrored. Yeah, to the right. Because we are starting to draw it at the x coordinates and adding the width. Well, now I did it so the x and y coordinate, or at least the x coordinate of the pad, is actually the center of the pad. So if it gets bigger, it goes in both directions. It grows in both directions. That's something I always wanted to do, and now I did it. Just making sure that the rest of the collision works. Collision with the pad, there we go. So box equals getPadBox. Underscore box here. My ball box next x and next y. And if there, yeah, and everything as we had. There's one thing I need to change still though, and that is where we're drawing the pad is not good right now. We're drawing the pad still in the wrong way. So let us fix this real quick. Oh my god. Let's go to the draw game function, and where we're drawing the pad is not correct now because we want the x and y coordinates of the pad to be the center of the pad now. Here. So we're gonna go local. Let's call it px. I'm gonna create like a helper variable here. Equals padx minus pad w divided by 2. And then we're gonna plug this guy in here, and in here, and in here. We're gonna replace all the pad x with a px here. Let's try this. Okay, the sticky function still doesn't work as expected. But first, let's see if the collision works. Okay, seems to be working. On the left, yeah, and yeah, it works from the bottom even as well. That's good. So that's working. Let's make sure that the stickiness works. Here, that should be in the center of the screen. That's where we're starting the game. But what I'm looking for is the serve ball function. Serve ball, there we go. So right now, yeah, just set the position of the ball to X. And this one is also set to 0. That sticky X was, I think, the X position of the ball. Let's try this. Ah, nice. Now it's nice and centered. And I get beautiful collisions. I don't get collisions with bricks just yet, but that's going to be kind of like the big next thing. Okay. So now that we are here, let us make sure that we are actually doing all the other things that we did previously in the ball update function. So let's see, what do we need to be doing? Right. There's a lot of things that we are now not doing. For example, we're not spawning trail particles. That's something that we're not doing here. Here's the end of the sticky if. So let's spawn some trail particles. That's kind of like the code that we had at the end here. Spawning trail particles and also checking if the ball has left the screen. So let's copy this part as well. Is that the part? Yes, I think it is. Here, I think the only difference with the way we are spawning those trail particles is previously we referenced next X and next Y, but now we're referencing actually the X and Y position because maybe next X and next Y are not actually saying where exactly the ball is currently. So here is we are checking if the ball has left the screen, and again we're doing this in a very similar fashion. We're checking if my ball at Y is greater than 227. Easy. Everything else stays the same. So let's see, this should work. It worked. And now we can... There's another problem here. We now cannot go with a pad to the edges. So that's something we have to deal with right now. Again, you change one thing and then suddenly all of the other things are also like, oh yeah, this doesn't work, this doesn't work. So let's see. So this is the game update function, update game. And here's where we are moving the pad right. So here is pad X. Minus, no, yes, no, plus pad W divided by 2. Oh, no, that's wrong. So this is correct. There we go, pad W divided by 2. This is this mid function that makes sure that the position of our pad is between two different numbers. Like so. Just making sure that I'm, yeah, touching this screen, touching this screen, touching you. Good. One more thing, when we're collecting pills, we also have to take this into account that our position of the pad is now calculated differently. So we're gonna go pad X minus pad width divided by 2, and pad, and the width is gonna be staying pad width. Pad X minus, okay. Pad Y, pad width, pad height. Okay, this should be working. Of course, we're not collecting pills anyway, so it doesn't matter. Just making sure that I don't have any errors. Okay, we don't have any errors. Huh, it works. It it works. It's so good. Okay, so let us continue writing this function. So there's two things that we have to do. First, the collision with bricks. But first, before we do the collision with bricks, let's just make sure that everything is happening the way it happened before with the already existing collisions. So collisions between the walls and the pad. There are some things that we left out. And that means that we actually have to differentiate, because different things happen when you collide with a pad and with the walls, right? So what we can do is now we add additional information to the collisions. For example, here, where we said, now actually let's go it here. Yeah, there we go. So here's where we collided with a wall. So let us add a new variable into our object of a collision object called t, suggesting the kind of type of collision we are doing. And the t in this collision, in this case, we're colliding with a wall, is going to be wall. And in this case, where it collided with a pad, is going to be pad. And so down here in our new collide function, where we're actually colliding, we can actually check for what kind of thing we collided with. So if C equals wall, we do certain things. Else if C.t equals wall, obviously. And if it's pad, then we do some other things. And we can already have some text for the brick, because that's going to be the third type of collision. Then we do some other stuff. Easy, easy. So what are the things that we're going to do when we collided with a wall? I'm going to put some text in here so it's easier to find later on. Wall collision. Not too much. Just some puffed and sound. So spawn puffed, we already had this previously. If you look this up, it's already in here, but it's kind of like very difficult to find because our previous function was so chaotic. It kind of grew very organically. Yeah, so here was the spawn puffed and SFX, right? So we're just doing the same thing right now. Now the collision with a pad, more things happen when we collide with a pad. And again, you can go back to the other function and look them up, but I already went over them and made sure that I have the things we need. First, we're resetting the chain to 1. Important. Then comes the part where you're changing the angle. This is this whole thing here. And again, all of this is already existing code. We're just copying it over. So here's the pad collision, and here's we're checking. Yeah, if we hit the top, then we're changing the angle. But only if we hit the top, and that's something we can easily do now. So for example, we can say, like, if the description of the collision is top, then we're actually changing the angle. Pretty neat. Pretty neat. All of this is already existing stuff. We rewrote some stuff because I think my ball is no longer there. Why am I? Let's go _b. So we have to replace all of the my balls with _b. Now there's some more. There is a catch power up. I'm going to put this in here. Again, already existing code. I think the way we calculate sticky X is different now. So this is how it works now. And again, it only works if you collide with the top of the pad, because if you collide with the sides, you shouldn't get stuck to the pad. And finally, there's the puffed and a sound. Again, all of these things already exist. You just need to copy it from this function and change the variables to different names. From this function. Here's the chain, here's the spawn puffed, here's the catch power up. All of this already exists. Okay, so let's try this. Let's see if we can change. Oops. See, this is now good because I kind of drove the pad into the ball and it didn't collide. That's good. Okay, changing angle is also possible. I can even change the direction of the ball if I change the angle. Let's see if we can get a flat angle. Also possible. Cool. Everything is working now. We're getting there. Okay, so let us start doing the final thing, the collision with the bricks. This is the part that is kind of like, this is tough. But don't you worry, it's not going to be that difficult. Right. Let me see real quick what I wrote there. Check for brick collisions. Ah, yes. Collisions with bricks. So I'm going to start iterating through bricks. So there's a for next loop with I through the number of bricks. And if we find a brick that is visible, that means, oh, there might be a collision with it because it's there. So let's see if we're colliding with this brick, right? So again, we're gonna define our box. We're gonna create a box. That's the same thing we did with the pad. Now we're doing it for the brick. So we're gonna have to create a new function that will create a rectangle, a box object for our brick. Get brick box, we're gonna call it. And we're gonna give it the brick as an argument. We have to still write this function. Actually, I already have this function here. Again, not a very special function. Here it is. So let me go down here and put this in here. Very similar to the get pad box here, by the way, because here's how the get pad box work. Here's how the get brick box. This is even simpler. Oops. To some extent. There we go. Here's the rest of it. Again, it accepts a brick and it just, creates an object that describes where the left, right, top, and bottom edges are and returns that object. Okay, so we create this box object, and now the same way in which we had the collision between the pad and the ball and the pad, we can have the collision between the ball and this specific brick. Easy. Let me see real quick. Ah, yes. Just making sure that I'm not skipping over some stuff. Yeah, so we're gonna see if there was some kind of collision. If there was no collision, then we have no problem anyway. And if there was a collision, then, well, we're gonna have to define that this was a brick collision. That's kind of like very important. You're saying, okay, this collision, we're gonna mark this as a brick collision. And it's also probably important for collisions to give this collision also kind of like a brick. So here's how I do this. I'm going to write this manually just so we can step it through step by step. So we're going to create kind of like a new property of those collision things. And some collisions will actually remember which brick it collided with. Just because later down the line we're going to react and we're going to do some stuff with those bricks. We're going to make them disappear. And so this collision will now remember which brick it collided with. Now here comes some stuff that we have to deal with later on when it's a mega ball. Because when it's a mega ball, weird things happen. So because maybe then you're not going to actually get reflected from those bricks. So that's something that we're going to have to swoop in later. But for now, we're just going to do the same thing that we had here, where we're just going to add it to the list of our bricks. Easy. And that's it. So now down here, we're going to have to actually react to the brick collisions. This is here. This is the brick collision. And this is very, very easy, surprisingly easy. Look at this. This is all of the brick collision code. We already have a function that deals with hitting a brick. We're going to give it the brick that we're talking about, that we saved in our collision object. And true means that it will actually progress the combo meter. And then if the brick is indestructible, just just like a special little detail that we didn't have before, but I kind of find it nice. So if the brick is indestructible, we actually spawning a puff of smoke. There's 2 more things that we have to change for this hit brick code to work. First of all, remember we're saving the speed of the ball before the collision to kind of make the brick bounce when it hits when it's hit by the ball. And we're not doing this yet right now. So I'm gonna do it. I'm actually doing it at save speed before collision. I'm doing it all the way up top. Here, where the first time we were looking how many collisions there were. See if there's collisions. So we're checking about the number of collisions. Before we do this, we're gonna save the speed of the ball, because the speed will now change after collision. And I want to make sure we preserve this to animate the brick correctly. And the other thing is we're going to go to the brick function, hit brick function. So right now the hit brick function accepts an index of the brick, like a number of the brick. But it would be nicer now. We're saving now the entire brick object. So let's now deal with the actual brick object. So instead of I, we're going to change it into B, and all of the bricks underscore I, we're going to change into B. Instead of always fishing the brick from the array, we deal with the brick directly. Not a big, actually it's better code because we're using less tokens, and we're actually really running really high on tokens right now because we have a lot of redundant code in here. So just replacing all of the bricks square brackets I with a B. As you can see, we're winning so many tokens. There's a lot of things that need to be replaced here. Okay, let's see if, there's another bricks I. Okay, that's good. There's one more thing that we need to do. There's when there's an exploding brick that also hits other bricks around it, so we need to rewrite it to work with this new hit brick function. And here it is. We just give it bricks J, like this. Okay, so let's try this. Bam, it worked. So here comes the big test now. Look how nice and clean this looks. Everything is nice and peachy. I wanna get the ball in there. You know what? I'm not going to do it right now. What we're instead going to do is we are going to start with the second level. So we can see if this works. Yes. Not sure why it reflected there, but hey, it doesn't get stuck anywhere. This is what we wanted. This is the future that leftists want. Oh no. Yeah, the collision with the pad is now a lot more precise. So we're gonna have to maybe deal a little bit, maybe add some lenience to it. I was actually thinking of making the pad smaller, but now if it's so sensitive, maybe that's no longer necessary. Looks very, very clean. Good. So there's one more thing that we need to get going, and that is the mega ball. You remember the mega ball? So the mega ball, if it's on, if the counter of the mega ball is on, it should fly through all of the bricks. It shouldn't actually get reflected. But that's kind of weird, because that means those collisions shouldn't get registered, or at least it should be registered in a different way. We should still keep track if we're colliding with bricks, but we're not going to put them through the collide function. The collide function is where we're reflecting, setting positions and reflecting, you know, because if we still did this, if we checked for the mega ball in here, then first of all, we would always get only one brick per frame with the mega ball. And also the ball would kind of like stutter as it flies through the bricks, because it would always like snap to the next position where it collides with the next brick. I want to just go like through the bricks. So I was actually thinking about how to do this, and this is the reason why I coded ahead, because this was kind of like, okay, how do I do this the best? And I think the best solution is to create a second array of collisions that is going to be called mcols. This is kind of like mega ball collisions. And so if the mega ball is on, I will look through all of the collisions with the bricks and put all of the collisions that we found in the mega collision array. And so later on, we are going to react to the, for example, to the indestructible brick collision with the mega ball, because the mega ball doesn't destroy indestructible bricks. But all of the other bricks that we found, those get all triggered, but we're not going to collide from them. We're not going to reflect from them. Okay, so this is the mega collision array. And then so what we're going to do here is the same code that we had here, by the way. See, if timer mega is greater than 0 and brick is equals indestructible. So if the brick is indestructible, it doesn't matter if we have the mega block, mega timer on, we're still reflecting. And if the mega timer is off, we're always reflecting. So we're going to take the same code and put it in here. And here. So we're going to go if it's a brick that we want to collide with, or if we have the mega ball but it's an indestructible brick, then we are colliding with this, or we're reflecting from this. Otherwise, it's we have the mega timer on, and it's not an indestructible brick, so it should get added to the mcols thing. We won't reflect from it because we're not adding it to our regular collisions. We're adding it to some special type of collisions that we're going to deal with in a second. And then there is like a little function. There we go. So here's where we're dealing with the actual collision. And here's where we're dealing with the mega ball collisions. So if there is any entries in our mega ball collision array, we're going through all of them and we're just going to hit all of the bricks. That's it. So now we're going to have to need we need a level where these things all can happen. So we need something with power-ups, I guess, right? Like this. Nope, that's not a good one. What about this one? Oops. Yeah, that's a good one. So we're gonna have a lot of power-ups here. Just checking all of the things that are happening. So expand looks good. Multi-ball, it works. Here's sticky. Sticky works. Slowdown works. I want the red one. I want the mega ball. There's the red one. Yes, it flies through. Yes. Oh, beautiful. Look at this. This is so good. Oh no, lost it. Just playing it for a while to see if there's any other problems. so sick. It reflected in the wrong way. Oh, this is such a good game. This is getting such a good game. Good, so this rewrite, ladies and gentlemen, seems to be almost finished. There's one little detail I wanted to add. And that is the way our levels are generated. Something I noticed every now and then when I was like over and over again when I was designing the levels. I'm still like working. I will show you in the next episode. I will show you how I'm doing the levels. But for now, I want to fix a little problem that I'm having. Here, where we're building the bricks. Where we're adding the bricks here. So right now we have like a gap at the top of the screen, you know, when you're starting this. The bricks don't go all the way up, and I don't like this. I like when I design the level, sometimes I want the bricks to go all the way up to the top. So where are we adding them? Oh man, I lost it again. I lost it. Add brick, there we go. Here it is. So I think 11 was a good number. Yeah. Might be 10. No, 11 was the right number. Yeah. So now there's like the same spacing to all of the edges, and I think no ball fits in between there. So we have like a little margin there, and then all of the bricks begin at the top of the screen. So if I want to have a margin, I have to actually design it into the level. And you know, a lot of levels will probably have a margin because it's kind of like part of the game. You want to get the ball all the way up there to get all of the massive points. Oh my gosh, this is so good. Oh, I lost all the balls. This is so good. Everything is so good on this. Oof. Collision detection is just so much better now. Good. I'm sorry, this was a long one. I also did it all in one go. So this is probably the longest episode that we ever did with over 1 hour of coding. But you know, gotta have better collision. So this is gone now. Also, the decoration is gone. So now all we have to do now is level design and some gameplay tweaks. And that's probably something we're going to do at the same time. So what I want to do is I want to now design a couple of levels, and I'm going to start playing them, and I'm going to see if, you know, I'm going to see how things work, if there's any gameplay tweaks I'm going to do. Again, maybe a smaller paddle. There is something I also noticed in the collision detection where it's like, again, still working in collision detection, driving the pad into the ball. So this is not going to be actually changing the gameplay. Right now, what happens is, because we did this like special collision detection, is if the paddle is moving into the ball and the ball is moving away from the paddle anyway, then there won't be any collision because the ball checks for the opposite side of the paddle, which is fine because, you know, you drove the paddle into the ball and it would get lost anyway, right? There's no difference, but visually it kind of looks weird because there's no collision between the ball and paddle. So it would be nice if, you know, at least if you did this, you actually see the ball flying away from the paddle, like at a higher speed than usually. So you kind of like, or let's call it lost ball. We have to flag the ball. Okay, no longer collision detection with this, and we're going to accelerate and stuff like that. You know, do some funny stuff. And also, since we're here, I almost forgot, let's clean up a little bit. There are some functions we no longer need. I don't think we need ball blocks. And we don't need Devil X anymore. And also here, we technically, we also don't need update ball anymore, update ball old anymore. Cleaned up a lot of tokens right now. Hopefully I didn't do any mistakes. No, I didn't do any mistakes. Good. Cleaned up a bunch of functions we no longer need. We still need the box collision because we're using the box function, this one. We still need this because we're using this to check if the pill collided with the pad. Okay, this is it for now. It's very late. Next time around, we're gonna be back with some level design and some gameplay tweaks. And then we can actually publish the game and do some playtesting. We're gonna actually post it on the Lexaloffle forums, and we're gonna ask people if they like it, how long they'll take for different levels, if they found any bugs, stuff like that, you know. See you next time around, guys. Bye bye.